Hi everyone. This video is a continuation of a code base that I've been working on in my last few videos. And just as a refresher, you can see I've got three files here: main.cpp, book.cpp, and book.h. And this is part of a video sequence with this code base where I've been introducing the basis of using classes and object-oriented programming in C++. So the example that I've been using is this simple book class. You can see I've got a lot of comments here describing how things are working. Book has three private attributes: title, author, and num pages. In my most recent video, I changed num pages from an integer to an int pointer in order to show an example of how to work with dynamically allocated attributes or member variables of an object. Down here, you can see I've got two constructors: a default value constructor and explicit value constructor. I've got a destructor, and this destructor, I'll show you real quickly, does actually deallocate the dynamically allocated num pages that was allocated in both of the constructors, the DVC you can see here, and the EVC you can see here. All right, lastly, it's got some standard getters and setters, and then a little utility member function called display that simply prints out the values of the attributes of the invoking book object. All right, so what I want to do in this video is I want to take a closer look at constructors. Specifically, I want to show you how once you define a constructor, you lose access to the default constructor that C++ provides for you that does nothing. Then I want to talk about the rule of three and the copy constructor. In my most recent video, we were working on dynamically allocating objects and attributes of an object. We were working on that destructor that I showed you, and we found out that we actually had a double free that was crashing our program when we were allocating a book in this manner. We were initializing it with the values of another book object. Okay, so we're going to work on fixing this in this video. All right, so first, let me show you that this compiles. And let me just show you the output here. Okay, so we're doing the Harry Potter books. 1, 2, commented out 3 because it had problems, and then 4 and 5. These first ones are allocated statically on the stack, and this last one is allocated dynamically on the heap, and then going through and freeing that memory. So for the Order of Phoenix, this is using delete right here, and then we're seeing the other 3 Harry Potter books on the stack being deallocated in reverse order that they were allocated. Okay, so let me head over to book.h, and now that we have two constructors here, we've lost access to the default constructor that C++ provides for every class until you provide your own implementation. So let's say I were to comment out this prototype for the default value constructor and then head over to the source file and comment out the definition for this default value constructor. Before we defined the DVC or the EVC, there was a default constructor that did nothing. This code here would have compiled, this code here would have compiled, no problem. But let me show you that once you define a constructor, as we've done here with the EVC, we lose access to the default constructor that does nothing. So now this isn't going to compile, and it's saying error no matching function for call to book, which is our default value constructor. Okay, it's saying there isn't one anymore, even though before we defined this default value, or excuse me, this explicit value constructor here, there was a default constructor that did nothing. Okay, so I just wanted to emphasize that and show you an example of how, once again, when you define your own constructor, you lose access to that default constructor that does nothing. All right, so let me undo this commenting out and return this back to the state at which it compiles. So here's what we're going to do. We're going to learn about the copy constructor in order to try and fix this problem where we cannot initialize a new book using the values of another book. All right, so in book.h, right below the EVC, but before the destructor, I'm going to describe what a copy constructor does, and then we're going to provide a prototype for one, and we're going to provide a definition for one. All right, right here seems like a good spot. All right, so what is a copy constructor? So a copy constructor is a constructor, as its name implies, that is called when a new object is initialized with another object's data. So let me show you some example code of when a copy constructor would be invoked. So the first one we've actually already seen. That was that commented out code that I told you has a double free problem. So let's say we're going to declare a book. I'll call it B, and I'm going to initialize this book using some other book. So I'll just make a little note here where other book is a book object. Okay, this would invoke the copy constructor. A second case is where we're creating a book B by assigning to it the member-wise values of its attributes in other book. So once again, making a little note here where other book is a book object. Okay, the reason why this invokes the copy constructor, if a copy constructor exists, is because we are creating a book here. That is the key. So let me just make a note here that the copy constructor is not called with, say, book B, or excuse me, let me put this on the next line. B is assigned other book. And this is because this is not object creation since B already exists. This is member-wise copy assignment. Okay, so let me try to explain this one more time just to make sure it's really clear, and then we'll implement our copy constructor. Okay, so in 1 and 2, we're creating a book. You can see we have the data type of a new variable, and that variable is called B. Here, we're directly invoking the copy constructor, passing in another book from whose values we want to initialize B to have. In the second example here, we are using the member-wise assignment operator in order to initialize the values of B with the values of other book. Now, if a copy constructor is defined, then it's going to invoke the copy constructor. If one isn't defined, then it's going to default to member-wise assignment, which is what this operator is called when both operands are objects. All right, it's not going to be called with a line such as this. The key here is this is not declaration of a variable called B. This is just use of an existing variable called B, which happens to be a book. So this really is going to be, no matter what, the member-wise copy assignment operator. Okay, so let's do the prototype then for implementing this copy constructor. So here's what it looks like. It's going to be book and then const book reference. Okay, we could also have a const book pointer. That would be fine as well. But the key is we do need to do pass by reference or pass by pointer in order to make this a true copy constructor. All right, so let's head over to book.cpp and implement this book copy constructor. All right, so just to recall, we've got 3 attributes. We've got the title, author, and num pages. Title and author are not dynamically allocated, so we're going to be able to just invoke the string copy constructor, or excuse me, the string member-wise assignment operator to copy over its value. And then for num pages, though, we do need to dynamically allocate our own memory for the invoking object that's being created in order to store num pages, what it points to. All right, so title is going to be assigned other book.title. Author is going to be assigned other book.author. And then here, need to allocate this new book's own memory for num pages. So num pages is assigned memory address for an area in the heap to store an integer, and then the contents of what num pages points to, this area in memory, is going to be assigned other book dot num pages. But here is the key. Okay, so num pages, recall, is actually a memory address, so we're going to need to dereference this. All right, so this is the most important part here. Because we're dealing with memory addresses, we've got a pointer as one of our attributes. When we make a copy, we don't want to copy that memory address over, because then we'd have two books that are storing the same memory address. So a change in one of these books would actually persist as a change to the other book because they're sharing memory. We want them to be two separate, distinct objects in memory. So this new book we're making here is going to need its own memory address, but we'll initialize the value of that memory address to be the value at other books' memory address. So they'll have the same actual num pages when we follow their num pages pointers. All right, so let's save this. And now let's make sure this code compiles. Looks good. Shouldn't execute any differently because we're not invoking this copy constructor. But now we can uncomment this code out here. Okay, so I'm going to say copy of HP2 invokes the copy constructor if one exists. If one doesn't exist, then performs member-wise copy assignment. Okay, so now we have a copy constructor, so we're not going to get that default member-wise copying where we're going to copy a memory address over. Instead, we're going to create that new memory, get a new memory address, and then copy the value over into that memory address. Okay, so let's go ahead and compile this and run it. And now we don't have any double free issues crashing our program. Okay, so let me go ahead and comment out the copy constructor that we just created so you can see the problem that the copy constructor fixed. So this is the problem right here. Okay, we had two objects with the same memory address, the same int pointer. So one was freeing it, then one was trying to free it again in its destructor, and it was crashing our program. So this is what the copy constructor does for us, is allows us, since we are the programmers of book, to properly initialize memory for a book. Make sure that this doesn't happen. No sharing of memory. All right, so let me put this all back in and then make sure that our problem is gone. All right, so this really isn't the end. Okay, this is only the beginning. There is something in C++ called the rule of three, and I wrote it here at the end of my last video. And the rule of three states that if you define any of the following, then you should define all three. And the three that we're talking about here is the destructor, the copy constructor, and the member-wise copy assignment operator via operator overloading. So the idea is if you need to define one of these in order to make your class or your objects work properly, then you should define all three. So we needed to define a destructor because we had a dynamically allocated attribute and it needed to be freed when the object was about to be freed. So because we needed a destructor, that means we should have a copy constructor and an overload implementation of the member-wise copy assignment operator. So in this video, we just did number 2. In a future video, I will do number 3, overloading that assignment operator so that we could do something like this. And remember my distinction. There is no object being created here, so the copy constructor is not being invoked. This is truly the implementation of the member-wise copy assignment. So we've still got a potential bug in our code if any programmer tries to do something like, say, uncomment this line, then we would have shared memory because that pointer is going to be copied from HP2 into HP3. But we can fix this by overloading the member-wise copy assignment. All right, that's it for copy constructors in this video. Thank you for watching.